Dear all, to this lecture we are going to study about the properties of continuous time Fourier transform. So now you know what we mean by Fourier transform, what is the purpose of Fourier transform. We are using this Fourier transform for analyzing the frequency domain representation of a signal, or we are using continuous time Fourier transform for extracting the frequency components that are present in a continuous time signal. So it is having several properties. First property is linearity property. It states that if the signal x1 of t is transformed into x1 of j omega and x2 of t is transformed into x2 of j omega, then a1 times x1t plus a2 times x2t is transferred to a1 x1 j omega plus a2 x2 j omega. That means the linear combination of one or more signals get transferred to the linear combination of their corresponding transform pairs. Okay, so how we can prove this statement is that take the LHS. So I'm going to take the Fourier transform of a1 x1t plus a2 x2t. Okay, now if I'm taking the Fourier transform of this, I know that a1 is a constant, the Fourier transform is a constant, is that constant. Therefore I can write this equation as a1 times f1 a1 times f of x1t plus a2 times f of x2t. Okay, so it can be taken inside the bracket. I can write f of a1 x1 plus a2 x2 is equal to a1 times f of x1 plus a2 times f of x2. And you know that f of x1 is what? x1 of j omega according to the statement. Therefore, I can write this as a1 x1 of j omega plus a2 into what is f of x2 of t is Fourier transform of x2t. According to this pair, Fourier transform of x2t is x2 of j omega. Therefore, I can write a2 x2 of j omega. So, hence it is proved that the linear combination of two signals or two or more signals get transferred to the linear combination of their corresponding outputs. Okay. Now we are going to study about the second property known as the time shifting property of continuous time Fourier transform. Here the statement is, if the signal x of t is transferred to x of j omega, then the signal, the shifted signal, that is x of t plus or minus t naught. You know that t plus t naught means we are shifting the signal x of t towards left by t0 unit, and x of t minus t naught means you are going to shift the signal towards right by t naught unit. Okay, so if you are making the shift, then what happens to the Fourier transform is, in the frequency domain, one complex exponential get multiplied with the actual Fourier transform. Okay, so x of j omega is the Fourier transform of the original signal x of t, and the Fourier transform of the shifted signal x of t plus or minus t naught is equal to e raised to plus or minus j omega t naught into x of j omega. Okay, so here plus or minus indicating that if the shift is plus, then the sign will be plus. If it is minus, then the sign will be minus. Okay, so we can prove that. Take the positive case. Okay, so I'm going to write like find f of x of t minus t naught. Okay, now this I can write it as integral minus infinity to infinity x of t minus t naught e raised to minus j omega t dt according to the definition of Fourier transform. Now you have to eliminate the term t minus t naught. For that, what you have to do is substitute t minus t naught as equal to, say, p. Okay, so now you know that t naught is a constant that is indicating the shift, and t is the independent variable. So now we are going to shift that t independent variable t to p by substituting t minus t naught as equal to p. So if I am differentiating this, I can write d by dt. With respect to t, you need to differentiate left hand side, and with respect to p, you need to differentiate right hand side. So if I am differentiating, I can write dt as equal to dp. So dt changing to dp and t minus t naught changing to what? P. And from this equation, I can write t is equal to what? P plus t naught. And the one more thing, you have the limit of t from minus infinity to infinity. So if I am considering the lower limit of t, that is minus infinity, then p will also be having is equal to what? p is t minus t naught, that is minus infinity minus t naught, that is again minus infinity. The upper limit is when t tending to infinity, then I can write p as equal to t minus t naught changing to infinity minus t naught. As it is infinity, the output will be infinity. Therefore, I can write this equation is equal to integral p from minus infinity to infinity x of p, since t minus t naught is substituted as p, and e raised to minus j omega. Here you have a t, that changes to what? P plus t naught. So, p plus t naught dt. So, I can split this exponential into 2, e raised to minus j omega p plus t naught is of the form e raised to a plus b. E raised to a plus b is e raised to a into e raised to b. Therefore, this I can write it as e raised to minus j omega p into e raised to minus j omega t naught. So, from this factor, this product, I can take this e raised to minus j omega t naught outside the integral because it is independent on the variable p. Now, p is the, here p. So now p is the integral variable. This particular factor is independent on the value p. Therefore, I can take it outside the integral. Okay, so I can write this integral as e raised to minus j omega t naught integral over p from minus infinity to infinity e raised to minus j omega t x of p dp. Okay, so any signal multiplied with e raised to minus j omega p dp, it will be, this will be equal to what? This will be x of j omega. Okay, therefore I can write this as equal to e raised to minus j omega t naught into x of j omega. This is actually the shifting proof of the shifting property for shift t minus t naught. If you are having t plus t naught, then you will be getting like e raised to j omega t naught. The minus sign won't be there. Okay, so this is solved with the time shifting property. This property is having very much importance in this signal processing theory. And the shift factor also you need to consider. If you have a plus sign here in frequency domain, the exponential will be positive. Then the shift is minus, then the exponential will be negative. Okay. Now we are going to study about the third property known as the time reversal property. The time reversal property states that if you have a signal x of t and its Fourier transform is x of j omega, then if you are taking the folded version of that x of t, that is x of minus t, then the frequency domain representation is also the folded version of the actual frequency spectrum. Okay, that means if x of t is transferred to x of j omega, then x of minus t is transferred to x of minus of j omega. So we can prove this. Proof is, take the LHS, that means Fourier transform of x of minus t. If you want to find out the Fourier transform of x of minus t, you need to take the corresponding equation. So equation is integral over t from minus infinity to infinity x of minus t e raised to minus j omega t dt. Okay, so here also I am going to substitute minus t is equal to p. That means what? If minus t is equal to p, I can write minus dt is equal to dp or dt is equal to minus dp. That is the first thing. Now you have to take the limit, like t is having the lower limit as minus infinity. Therefore, p will be what? P is equal to minus t, that is equal to infinity. So, similarly, when t is taking the upper limit infinity, then p will be taking the minus t, that is equal to minus infinity. So, as t is varying from minus infinity to infinity, p will be varying from infinity to minus infinity. Okay, so if I am substituting that, this will be integral over p from infinity to minus infinity, x of minus t changing to x of p, e raised to minus j omega t is there. So, I can write minus j omega into t is actually minus p, that is minus p, into dt changing to minus dp. Okay, now what is the case is, this will be, this I can write it as, integral a to minus of integral a to b dt is equal to what? Integral b to a dt. Okay, the lower limit can be moved to upper limit and upper limit can be moved to lower limit, or we can interchange the upper limit and lower limit by multiplying that with -1. So this I can write it as, here you have a minus sign, that will come here. So minus integral p from minus infinity to infinity, you have x of p, and this I can write it as e raised to minus of minus j omega into p, then dp. Okay, this I can again write it as integral over, this is plus infinity to minus infinity. So integral minus of integral plus infinity to minus infinity is equivalent to integral minus infinity to infinity. Therefore I can write integral minus infinity to infinity, it is over p, then xp e raised to minus of minus j omega p dp. So here if you have minus j omega t, then this can be what? X of j omega. Here, since you have x e raised to minus of minus j omega p, this will be equal to x of minus j omega. So that is the proof of the time reversal property of Fourier transform. Okay, thank you.